Hello great hands, welcome to my channel. Hopefully this finds you well and perhaps well in time before your next exam. This is to help those who are still to write their paper 1 for the mid-year exams, hoping that this will help you. So we're going to look at this November 2019 paper, which was a national paper by the look. So let's see what is cooking here. Of course, please guys, read instructions carefully with understanding, committing these two to memory during any piece of exam. Here we are rounding off to 2 decimal places unless otherwise stated. We clearly show all calculations, diagrams, graphs. This is the part that often gets missed, that we have used in determining our answers. Please note also that diagrams are not necessarily drawn to scale, but at a proportional level, we should get the right message. If that is wrong, then it means the diagram itself is wrong. And we cannot have and accept wrong diagrams for exam purposes. That should be discouraged at a national level, because at the provincial level it seems nobody cares. We keep seeing these mistakes all the time. Anyway, factorize the following expressions fully. Now that part simply means we factorize until we can no longer factorize. So this is 1.1.1 from 1.1, okay? So we have 3y squared plus y. And we can factorize this by taking out the highest common factor, which is y. We remain with 3y plus 1. And here we cannot move further than this, so this is it. So we get a mark for taking out the highest common factor. So 1.1.2. We have x squared minus 10x minus 24. Now, we can factorize this by inspection. So we take x. What are the factors of 24 that we subtract and give us 10? So it's going to be 12 and 2. This minus 12 plus 2, right? Can we factorize further than this? The answer is no. Alright, so we get a mark for each of the 2 binomial factors. Okay, that's good. But now I would like to indulge you a bit on long division, because I just want to show you that this whole shenanigan came from long division. Because let's say you cannot factorize this by inspection, but you know the background of how to do this. Well, first of all, in this expression, guys, x squared minus 10x minus 24, we choose x values such that this thing gives us 0. All right, now these x values can be 0, 1, 2, 3, minus 1, minus 2, minus 3. Usually by the time we get to 3 and minus 3, if at all we are doing well, we should have found a factor, or should we say a number, that when we substitute it for x, the entire expression gives us 0. Now let's start. What can we do? We cannot put 0, obviously, because there's a constant here. So the 0 will only kill the x terms, and minus 24 remains, but we want 0. So can we put 1 in there? So if we put 1, it's going to be 1 squared, which is 1, minus 10, that's minus 9, minus 24, that gives us minus 33. Again, 1 doesn't work. 2, we get 4 minus 40, So that's minus 36. Minus 36 minus 24, that's minus 60, so that's wrong. 3, what do we get? This is 9. Minus 90, that's minus 81. Minus 81 minus 24, that's going to be minus 125. So technically, is it minus 105 here? Minus 105. So that doesn't work. So we leave that part. What about minus 1? This is going to be 1 plus 10, that's 11, minus 24. So 11 minus 24, yes. Minus 13, doesn't work. We put minus 2 there, we get a 4. This is 20. 4 plus 20, that's 24. 24 minus 24 is 0. So this one works. As soon as we hit 1, we then say, well, we put x is equal to 2. Sorry, minus 2. But remember, when we factorize, these are factors inside a bracket. So we reverse the situation. We can say, therefore, x, we transpose this back. It's going to be plus 2 is a factor of x squared minus 10x minus 24. Right. So we then say, okay, we take this factor and put it as a divisor. And we take our main expression as a dividend. Then we start looking for the quotient, which is the other factor. So basically we ask, how many times does x go to x squared? It goes x times. Whatever we get, we distribute here. We multiply it there as well. So it's going to be x times x. This is x squared. Plus x times 2 is going to be 2x. Again, remember with long division, there's that negative hovering around, cancelling things. So we've got, once we distribute the negative, we're going to have x squared minus x squared. That's what we write. It's 0. Minus 10x minus 2x gives us minus 12x. We take down the minus 24. Then we ask again, how many times does x go to minus 12x? It goes minus 12 times. We do the same. Distribute minus 12 to x, we get minus 12x. That to plus 2, we get minus 24. Again, remember there's that negative hovering around. So what do we do now? Minus 12 plus 12 is 0. Minus 24 plus 24, that's 0. So it means basically x squared minus 10x minus 24 is going to be our divisor times the quotient. Right. As you can see, this uncovers these factors nicely for us. Great stuff. Although this is a lot of work, for those whose algebra is relatively tough and strong, this is good. As you can see, the reason why we kind of teach this shorthand technique of inspection, we can clearly see there's a lot of understanding that needs to come from setting up long division to factorize that expression. There's a lot of work. But some of you guys have got the calculators that can do this. So let's not even waste time going into that. I just wanted to show you guys where this inspection technique came from anyway. So that when a question that requires this to fully understand how to attempt it, at least you can do it, all right? Because it can come. Remember, whatever you're getting taught, it's just some sifted version of some heavy stuff behind it. And remember, higher order questions often go back to the heavy stuff that is being skipped when you're being taught these things. And that's where you get caught pens down all the time. Anyway, let's move on to the next one. So we've got 1.1.3. So what is the story here? We've got 9x squared minus yx squared plus 10y minus 25. So if we look here, we've got more than 3 terms, so it's not a trinomial. Usually, not always, usually factorization by inspection is not so easy. But perhaps trial and error may need to come in and then inspection. But in this case, we can see the terms are not even alike. So we can do this by grouping. So we can clearly see that, well, we can do this and say this is 9x squared and maybe put closer the 25 and group these. Take the negative for the next two. It's going to be y squared minus 10y. We group those. So we know that we took a quadrinomial into a binomial. Then in this, we know this is a difference of 2 squares. So we can actually factorize it. Here we know we can take out the highest common factor, which is y. So we remain with y minus 10. Here this is going to be 3x minus 5, 3x plus 5. And at this stage, we cannot go further than this. So this is good. So each one of these factors gives us a mark, and taking out the highest common factor there. That's how we can score those 3 marks. All right, another student may choose to group these differently and say, but I can just take 9x squared minus yx squared and group them together. That's a difference of 2 squares still. Then take 10y. Goodness, why is this y trying to become funny now? And then, of course, we group those. So this would mean, again, we have 3x minus y into 3x plus y. When we factorize that difference of 2 squares plus, the highest common factor here is 5. We get 2y minus 5. So this is good too, because we would get a mark for those anyway. So here, 2 possible answers. Again, guys, when the answer looks a bit strange, try to reverse the situation and see if we can get back to the original. If we can, that's how we can check that what we did is correct. Okay, if you don't trust the reversing, just choose a value for x and for y. Evaluate that which you got and then do the same into the original. If you get the same answer, then it means what you did is perfectly fine. Alright, so please guys, be in the habit of checking answers, because we lose marks over some careless mistakes we are not so aware of only when it is too late, when the scripts come back with a very bad percentage, and then you realize, oh my god, I kept making mistakes. But if you check your answers every time you solve something, believe me, you will not have that moment where you regret. Alright, this is equal to, now the denominator here is 1 and this is 1, so literally our LCM here becomes x times 1. So this is basically x. So just multiply that x, or just call it cross multiplication. This is going to be 4x plus 1. This is going to be 2x minus 3 over x. Okay, using the same technique. There are many ways of killing this cat, but the fact of the matter is the cat must die. So we see brackets we don't want. Remember, whenever we simplify, guys, we do inverse operations. So this means we apply our BODMAS in reverse. If we have brackets, we expand. If we had it expanded, we put brackets. Okay, just think about it that way. So numerators multiply, so this is going to be 4x plus 1 into 2x minus 3 divided by the denominators multiply, we get x squared. We FOIL out the top, so this is going to be the case, like that. So we get 4x squared. Then this is going to be minus 12x plus 2x is going to be minus 10x. This becomes minus 3, all divided by x squared. Now x squared can still be done something about. So this is 4x squared divided by x squared minus 10x divided by x squared minus 3 divided by x squared. Remember, that denominator divides each one of the numerator terms. Okay, so now we have some nice things happening there. That sits in the background, that takes the square, and that's it. So we end up with 4. Did I say 4? Goodness. 4 times 2 is 8. Yo, this guy is committing suicide. So this is 8. So we end up with 8 minus, if we look here, it's going to be 10 over x minus 3 over x squared. Now at this stage, there's nothing more we can do. So I feel this has been done to the best of our knowledge. Of course, another student may write this as 8 minus 10 times x to the minus 1 minus 3x to the minus 2. This is a possibility. There's no crime in doing that. But during my grade 10, grade 11 years, we were never allowed to leave our answers with negative exponents and square roots on the denominators. We were forced to rationalize each time, unless otherwise stated. But these days, you just choose how you go about business. Okay, how do we score marks, folks? Well, I think getting to this step is key. And the answer, considering this is another way we can present it. All right. So how many marks was this? 2. Wow, that's bad. So many things, but anyway, it's not a big deal. We move on. All right. In fact, another student could have just foiled out straight away and never tried to simplify these brackets, Just foil. 4 by 2 is 8. 4 times this, it's going to be minus 12 over x. And then this times that is going to be 2 over x. So same denominator, so minus 12 plus 2 is going to be minus 10 over x. Nice. Then this one is going to be just 3 over x squared. So it would have been easier. Actually, one could have jumped straight up to this step. Maybe that's why it's 2 marks, I guess. It was easy to do so. No problem. No problem. No problem. So, what is the next one? 1 point, yikes, what did I do here? This is 1.2, that was 1.2.1, 1.2.2. So we've got 5x minus 5 divided by 5x. So we saw from above that the denominator divides each term in the numerator. So we reverse this thing, call it partial fraction decomposition of some sort. Well, these two are common to each other, so they divide nicely. 5 and that divides nicely. So when nothing remains, 1 survives whatever happened. Then here we've got 1 over x. So this is it. Of course, one could still write 1 minus x to the minus 1. That's still okay. I'm not too sure though how strict the curriculum now is in terms of negative exponents. Anyway, how many marks was this? 2. Okay, showing that, and the final answer should be okay. Now we have 1.2.3. We've got 3 to the exponent x plus 1 plus 3 to the exponent x divided by 27 times 3 to the exponent minus 1 plus x. Alright, so we can clearly see that what we have here is going to be 3 to the x times 3 to the 1. We use exponential rules here to split those into their factors. At this point, 27, it's on the multiple, so there's no sign, there's no addition, so we don't need to waste our time with that. So this is going to be 3 to the minus 1 times 3 to the x. Okay, I'm just going to continue this side, although I don't like to do this side by side kind of thing. You know, 2 equal signs in line is not such a good idea. 3 to the exponent x is the common factor. We factorize. This is 3 plus 1, all divided by 27. Now we can change this and say this is 27 over 3, because that's what this is, times 3 to the exponent x. We can move quick. That divides that. So our answer here becomes 4 over 27 divided by 3 is 9. Okay, I just wanted to keep the space, otherwise I don't like to go about business like this. Okay, good. So now folks, I just want to highlight something. Please avoid, this is 3 to the exponent x plus 1. Avoid saying 3 to the power of x plus 1. For example, if you read this as 3 to the power of x plus 1. Do you know what you are saying? If you're reading this out and I don't see it, to me, when you say 3, 2, once you say 3, 2, this means this divides 3, meaning 3 is the divisor. So this is what you mean. And the power here, you are saying, once you say power of, you are suggesting that this is the base of whatever that power is. So let's see now. What you mean when you read it like this, you're meaning x plus 1 to some questionable exponent that we don't know is divided by 3. That is exactly what you mean mathematically. That's if, of course, you understand mathematical language and its implication. But if you don't, of course, some more. Anyway, guys, sometimes, yeah, I talk too much and I should stop. Anyway, folks, my intention here was just to show you that a power of whatever number you will state, it means that number is the base. But now, of what order is this power? That means we cannot evaluate this thing because there's many possibilities. Okay? But now, here's another thing. Let's say you negate the of. You write 3 to the power x plus 1. Because, of course, there's many ways of trying to dodge the bullet here. Do you know what you mean? Yes, this is possible. This is possible to be a power. And when we don't state what it is, we mean that's the first degree power. So literally, you are trying to say x plus 1 divided by 3. Because 3, 2, it means 3 goes how many times to this power? By the way, this power, once you know the value of x, that could be 7 plus 1, which could be essentially 2 cubed. Can you see? Definitely 8 is a power of base 2. And which degree is this? It's a third degree power of base 2. So essentially, be very careful of saying things that don't make sense, guys, because at times we refer to things wrongly because we don't understand the use of mathematical language. Remember, maths is a language, guys. And like in any other language, there is grammar in that language. So don't just think because this is mathematics, you're going to bend the grammar. The moment you bend the grammar, you're not saying anything to a mathematician. You're actually insulting them. Because at some point you just show that you don't belong in mathematics. You get it? Because honestly speaking, you cannot say I'm part of this club and then the next thing you're saying things like a crazy individual. I mean, think about it. A crazy individual needs psychiatric care, right? And they need to be taken away for a while until their brain can really see better. So please, guys, don't say things you don't understand. Be very careful. Do not assume. Maths is not based on assumptions. It's based on truth. Maths never lies. Even when we approximate, maths is very, 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 very good in that it doesn't hide when it doesn't know. When maths doesn't know, it approximates in the best way possible. But when it does know, it says it confidently so. So we cannot be making assumptions or presumptions. I thought it meant. No, don't think it means. Know what it means. If you don't read, study, read different books, different texts. You guys have access to the internet nowadays. We did not. So we really did not rely a lot more on the outside than what the teacher says. You guys are more at liberty to explore other things. Even teachers you would dream to be taught by are actually teaching you for free on these platforms. Imagine how much money you would have to pay to attend their classes. And those who actually sell their content, they even sell it cheaper than they would if at all, things were normal or under normal circumstances. So please, folks, even the price tag that those who actually teach you put, it's actually much cheaper than you would have to pay if you were to attend the schools they teach in, all right? If at all they are teachers, or their private classes for that matter, if at all, we didn't have this social network, because luckily the social networks kind of put those prices down because you don't really have to pay for much, but you can gain a lot by just a little. All right, so please, guys, be very careful. Many people have a tendency to follow the wrong path than a few individuals who sometimes are looked at as crazy, but they always get it right. I will promise you, multitudes are almost always wrong about something that is technical in nature, of course, not general stuff. General stuff, the multitudes are always correct. But when it comes to technical matters, the multitudes are usually misled and misinformed and essentially lost. So whatever direction they take, usually it's in ignorance of the facts, okay? But the few that usually get demonized and made to look crazy sometimes, they always have it right. I'm saying always, not sometimes. They always have it right. Because for them to even separate from the multitudes, it means it took a lot of introspection and a careful examination of the issues. And so they came to a conclusion no simpleton can get to. All right? Sorry for the harsh words, if at all you interpret them as such. But this is the reality, guys, we need to face. By the way, if you are a mathematics student, you should not take any offense, because you know the gymnastics here twist everybody's neck, including myself. There are questions I cannot solve at a go. I need a second look, I need a third look, and a fourth look. Perhaps no look at all to get it right, but except for someone to show me. Okay? But I know most of the problems I can solve on the fly. Okay? I can solve them on the fly. Others, I need a bit of a background check, maybe a bit of revision here and there. Because guess what, guys? This is not what I do for a living. This is what I do for fun. For me, this is a hobby, to show you these things, to teach you these things. It's not a job. I don't do this. In fact, I'm actually wasting my time by doing this, because I should be studying my work, advancing in my work, getting better at my work, starting to look for more opportunities. But at the same time, guys, we cannot forget where we come from, right? We know how hard it was for us to make it through high school on this subject. It wasn't easy. This is why we have decided we're going to share a little bit of our experiences with you guys, so that you can have it easy, so that your talents can just be unleashed. Mind you, our talents were caged. If the teacher didn't know maths and teaches you, you were only limited to that teacher and the textbook that the school uses. And if that textbook you didn't understand how it's written and what it does, you were doomed for life. You didn't have a choice, because there were not so many schools to even go to, because we had to choose a school that you can be in close proximity to. Because if you cannot use a car to travel, you can walk there. And most of the time, we walked to school than we actually traveled to school on bus or cars. Now, this has been broken. And guys, you should be taking advantage that that issue has been broken. You're not limited to your teacher in terms of knowledge and understanding. There's even free textbooks, e-books that you can download. Books written from many countries around the world. Just keep your eyes. Go to websites where you can download textbooks and just type whatever you feel, whatever you're looking for. Check on the internet. Just type mathematics textbooks. Of course, in different countries, they have different ways in which your level can be expressed, you know. For you, say for example, in the US, you know, I don't know, there's a slight difference of how high school works and college works, you know, things like that. So be very careful. At times in those countries, you'll find that, as it is in our country, of course, in our country you will notice that our high schools have college equivalents. Grade 10 is an N1 in our TVET colleges, or colleges, if I can put it that way. N2 is grade 11, N3 is grade 12, literally, that's what it is. Then the actual tertiary starts at N4 level, if you're in a college. And of course, you can go to university. But again, you can choose to finish up until N6. All right, so that's the idea behind everything. And then in other countries, you'll find that, of course, grade 12 is considered some course in college or whatever. The books sometimes are similar, but the content sometimes varies a bit. But download these books, check them out. Please, guys, read. Don't be people who like simplified versions of things. Read the content. Struggle with the heavy load. Then get to these channels of ours and many others who do a good work here. Then see the simplified versions of things. But don't limit yourself with simplified versions. Mind you, you are just limiting yourself to the simplified understanding of a complex issue by that individual. So this means you will always need that individual to ever solve anything going forward. But if you take the heavy load and then you come for the simplified version, then it enhances your understanding. You start to see how to pick important points. And from there, you become independent of that individual. And this means you can actually enlighten others as well. Okay? So don't limit yourselves. At the same time, know what is right. All right, guys. So let's have a look. How would one check if these answers go back to the original? Because especially this one, if you take this one back, it wouldn't go back to that, right? It wouldn't. It would take some skill to do so, which you should know already, but I know you don't know. So let me tell you, how would you take this back? Okay, guys, let's just teach you some things now so that you know. If we take this back, we'll start down here, right? Multiply there, we're going to get x minus 1 over x. But that's not 5x minus 5 over 5. So what do? In math, we can multiply by 1. But this one is strategically going to be 5 over 5. So when we do this, we get 5x minus 5 over 5x. But this was just multiplying by 1 strategically, depending on what we want. So we're basically forcing our hand to show that this thing can actually go back. But it doesn't go back so nicely. Sometimes you wouldn't know and think about what I just did. So what do you do now to then ensure that what we have here is the same as what we have above? Just choose a value for x and say, for example, x must be 1, but x cannot be 0 because it's on the denominator. So say 1. So this is 1 minus 1, which is 0. If x is 1, so this is going to be 5 minus 5, that is 0. 0 divided by 5 is 0. So can you see the result is the same? So it means our simplification is good. We come back here and do the same and say, let's choose 1 for x. And then evaluate this on the calculator and see if we're going to get 9 over 4. Because it's going to be very difficult to reverse this thing into what we have. Yes, we can, but it's going to cause us a few issues. All right? Which you are not ready to face, okay? You are not ready to face those issues. I will show you though. Sometimes I like to show these very strange techniques so that you are very flexible and you are confident. For example, if you wanted to kind of reverse this situation, you would know that 9 can be expressed as 3 times 3. Therefore, you will split 4 into 3 plus 1. Already going back. And then you decide, okay, all right, okay, what do I need? I need 3 to the exponent x. So it is logical to just multiply by 1, which is made up of 3 to the exponent x divided by 3 to the exponent x. So can you see we end up with that? But now the question is, how do we then generate the 27? Then this becomes a bit of a situation, right? Right. But do you see we have 3 times 3 here, and then 3 to the exponent x. So to generate this 27 would require some crazy technique. But I think let's just avoid all those kind of things. But just to show you what I'm talking about, if you wanted to reverse this the same way I did above, you would say 4 over 9 is as good as 4 over 3 squared. Maybe let's just say 3 times 3. Now we're like, okay, the denominator tells us that we can split that into 3 plus 1 over 3 times 3. Right. Now, what do we want? We want the 3 to the exponent x. So of course, we can multiply by 1, which is 3 to the exponent x, 3 to the exponent x. So what do we get? 3 to the exponent x into 3 plus 1, all divided by 3 times 3 times 3 to the exponent x. Great. Now, we are like, okay, all right, okay. We've got something now. We We understood that 9 was 27 over 3, right? This one right here. It was 27 over 3, of course. But now the question is, why would you choose 27 over 3? Well, we're forcing our hand. Because if we saw that there's a 27 in there, 9 may have come from 27 over 3. Where did it come from? Well, that's a problem. But we cannot deal with that issue there. So we can just go back and say this is 3 to the exponent x into 3 plus 1 divided by, of course, this 9 is 27 over 3, okay, times 3 to the exponent x. This is still 9. So, of course, this is now employing a strategy because we know what the answer we are trying to get to has. So we try to showcase it in a way that can help us to go back, okay? And from there on, we have our expression back. You get it? We get it? Yeah, so again, you look at what you have and look at what you want to go back to. And then you play with the strategies. Of course, you choose what is feasible because certain things, it's just a matter of a choice. And you have to accept that when you're trying to force something into something else, there are certain compromises you're going to have to come across. But of course, if you don't want to do all of this to see that this actually goes back, because this part looks like cheating. The rest looked easy and nice to follow. But this one is questionable. But 9 can also be something else. It can be 81 divided by, say, 81 divided by 9. Could have been 81 divided by 9. Yeah, for sure, that's true. But can we simplify that? We could. So at the end of the day, guys, whatever you say, whatever you do, just know it's going to end up where you need to go, though, usually, even if you choose other things. But again, guys, I'm just showing you the gymnastics and the tricks that you can use to get the stuff done. So please be aware of these kinds of things because you will get questions like this. I'm promising you. The fact that I have shown you now, just remember, it may just be there in the next exam. So don't avoid these things. Don't overlook these things. This is what makes you cry about maths because nobody shows you how to reverse things and how to actually drive things in any direction you choose they should go. Of course, using acceptable mathematical techniques and tricks. Anyway, what we do, guys, we just choose a value for x. Choose one, just an easy one. Don't choose big numbers because the last thing you want is to evaluate infinity, which would give us a math error. So this is going to be 3 to the exponent 2 because if we say x is 1, that's going to be 2 plus 3 divided by 27 into essentially 3 to the exponent. This one we're going to say 0 because it's going to be minus 1 plus 1. And guess what? We get 9 over 4. So this shows that, yes, our simplification is perfect for that expression. So we can sit comfortably knowing we did our job. Of course, whenever we factorize, that's max. That's max. Okay? Getting 3 marks. Maybe converting this to positive exponents. Maybe. And the answer, I suppose, because there's not a lot elsewhere. So, okay, guys, that's how we would take those 13 marks, and move on with our lives. So please, no mathematical grammar, okay? Maths is a language. It has order. It has syntax. You just don't say things however you wish. you say things in an acceptable way, because you're not talking to yourself, you are talking to others. Great. So let's get to question 2. Okay, so we're dealing with algebraic expressions. This time it's usually algebraic equations. We're solving for something. All right, so we've got 2.1 with 2.1.1. We need to solve for x. Now remember, question is we're solving for x. So this is 2x squared minus 10x equal to 0. All right. So we can see there's a highest common factor of 2x into x minus 5 equal to 0. Therefore, x is going to be 0 or x is going to be 5. Of course, you guys can go about it the long route, but if you are doing grade 10 already, you are in high school. You see, you know, people who are doing grade 8, grade 9, they're not exactly in high school. It's just that, you know, we're trying to copy too much what happens overseas, because for them 5, 6, 7 is high school, and then 8, 9, 10 is college. You know, call it college, because guess what, we also have colleges that have high school equivalents for us, because grade 10 is N1, you know, grade 11 is N2, grade 12 is N3, stuff like that. Okay, so they kind of wanted to absorb grade 8 and stuff, but look, in our country, those were juniors. You know, I'm at JSS, right? I'm at JSS. Those are junior secondary, because that's not secondary school. Secondary school is high school. Junior is anything below high school, but of course we call them junior secondary, because yeah, you're doing things that underlie on the school, what is coming in secondary school. Okay. So okay, guys, bani rob but in high school students, got grade 8, grade 9. You are not high school students. You are junior high school students. Anyway, whatever. So of course, guys, it seems like the marks are on the answer, but I feel there's an extra mark for factorization, because that's a technique that is mathematically, you know, mark worthy. It's a skill to perform it. So this should be 3 marks. Again, guys, questions like this, you check the answers. If you place 0 where x is, we get 0 on the left hand side, and 0 is equal to 0 on the right hand side. So this is a good solution. 5, this would be 25 times 2, that's 50. This is 10 times 5, that's 50. So 50 minus 50 is 0. So 0 is equal to 0. So the equation balances. Then we can leave this question convinced we have solved it, because there's no way the equation is going to balance and our solutions are incorrect, provided our expression is copied correctly from the question paper. If not, then that's a disaster. Okay, remember that. So this is px minus kx equals k minus p. Of course, this one has more than 4 terms when it transpose everything, so we might as well group everything. So we group whatever has p together, minus kx minus k equal to 0. We factorize here by taking out the highest common factor, p. In fact, you can already show the grouping here. But if we take out the negative there should be plus inside, okay? Remember that. So this is p into x plus 1 minus k into x plus 1 equal to 0. So we still have we still have x plus 1 is the highest common factor, and what remains is p minus k equal to 0. So we will notice something, that these two are literally constants, right? And now if these are constants, it means they are like terms. And if they are like terms, we cannot solve this equation if this bracket is 0. So we can easily say here, I think it's safe to split the solutions here because not splitting them is dangerous. We can easily say, well, x plus 1 can be 0, right? Right. Or we can say p minus k, however, must never be equal to 0. Because if that is 0, then this whole thing washes away and we run into problems. Okay? So this is a higher grade question, truly speaking, because how you solve this one is not the usual way. You know how? It's a bit naughty. It is a bit naughty. Now let's have a look. We will then say, therefore, x can be equal to minus 1, where p must not be equal to k. I think that is a strong condition. Without that condition, we will lose the third mark because we cannot solve this expression if at all we are not aware of what is going on here. So usually, folks, factorization, I would say this factorization, the final factorization, becomes important here. The x value becomes important. The restriction becomes important. Because without that restriction, this problem cannot be solved. So be very careful of restrictions when solving algebraic equations or expressions. It is very important. If you don't spot it, you're in trouble. Now, if we're saying these are not equal, we can check if that's the case. Let's say p is 1 and say k is 2. As long as they're not equal, we don't care whether signs or whatever. They just must not be equal. Now we take this back. So p is 1. So this means we've got x minus 2x is equal to 2 minus 1, right? Now, let's substitute the x value. So this is minus 1 minus 2 into minus 1 equals to 2 minus 1. This becomes 2 minus 1, which is 1. This is 1. Can you see the left-hand side is equal to the right-hand side? When these two dudes are not the same. If they were to be the same, we would have a problem. You get it? Let's assume they are the same and say p is 1. And say k is 1. All right, p is equal to k equal to 1. Let's see what happens. So this would be x minus x equal to k is 1 minus 1, right? Sebenza ne? Because x minus x is 0. So of course, now remember, we're not going to try and solve this immediately. We're going to put the value of x that we got when we say these two are equal, just to show you that it wouldn't work. So this is minus 1 minus into minus 1. Bafethi ngathi yaspana nje. Usebenzelani ke ngoku wena? Hayi man, bengafanelanga uspane mfethu. You must not work, kaloko. So this means this is minus 1 plus 1. Well, this is 0 is equal to 0. Sinenkinga kodwa. Anyway, guys, when we substitute, this seems to work. But we cannot have a factor that is 0 for a particular expression, right? It's dangerous. Because this cannot be equal to 0 as a whole, right? I mean, p minus k must not be equal to 0, because if that thing is equal to 0, then we will have a problem of not being able to solve for x. I don't know why in betrayal ke ngokulento, because yavele yangibetrayal away like fast. ingijwayera kabi. Angiyazi ukuthi why sengijwayele kanjena manje. Anyway guys, angazi sesivele yaniphaphela. But I think you understand though that if these are constants, then they must not be equal for us to have a solution here. Because it means we need to divide by this. This is another way of one looking at this. If these are constants, it means we would have x plus 1 maybe into p minus k. Then we divide by p minus k equal to 0 divided by p minus k. Now if this thing is 0, this means this would be 0. Now division by 0 is undefined. Can you see that? Even here it would be undefined. So I suppose, although the checking kind of betrayed us because it should not have worked, to highlight the fact that p cannot be equal to k. But I think it's significant to show that since p and k are constants, maybe we can even further put some explanation here and say, look, we mean what we say, p must not be equal to k since p and k are constants. Okay, curtains are mukbala kahle. Since p and k are constants. This is not a very simple question to solve. It's easy to botch it, but the question is, for us to be able to solve for x, p must not be equal to k. Because if they are equal, we will have a problem. Even if you think about it, if p is 1, k is 1, x disappears already. And when x disappears, we can't solve for x, essentially. So the third mark is for the restriction. And if you like, you can provide some very valid reason as to why those two should not be equal. All right, let's do 2.1.3. So we've got 2 to the exponent x over 3 equals 1 over 128. Okay. So question is, can we express 1 over 128 as perhaps a base of half, maybe? Or should we say 128, can we express it as a base of 2? Well, sometimes you don't remember these. Just write 128 equals 128 in the calculator, then press shift and then fact. Okay? Because sometimes it gets overwhelming, you know? It gets overwhelming. What happened to my calculator now? Here, 128 equal to shift fact. I don't know. I was evaluating some complex numbers. I don't know how I got that in. Anyway, so this says this is 2 to the exponent 7. So nice and easy. We can say this implies that 2 to the exponent x over 3 is equal to, we can say 1 over 2 to the exponent 7, because this is what it says. You can check and say 2 to the 7 gives us 128. Or you can do trial and error, keep on trying numbers until you get to it, but I think this is the quickest way to get to business. Remember, also using the calculator is a skill on its own. So using our knowledge of how to reverse things, exponential rules, so we know that this is 2 to the exponent minus 7, changing from negative exponents to positive exponents. Now same basis means the exponents are also equal. So this is going to be over 1, cross multiply. We then know that x is minus 21. Nice and easy. Again, this is an equation. So what do we need to do? We take back the value into the original. 2 to the exponent. We put 27 over 3. Not 27, sorry, 21 over 3. Was there a negative? No? Hehehehe. Okay, so let's see, what does that give us? It gives us 128. But it doesn't give us 1 over 128. Oh, I forgot. I should have put minus 21. Goodness. Not 21. Okay. Now that's good. So my left-hand side is equal to the right-hand side. As you can see, guys, mistakes just keep showing up. So knowing how to do these things comfortably so is what will protect you from a disaster. You will know when something is not adding up. You will know why it doesn't add up. The fact of the matter is, let these mistakes be uncovered while you still have time to rectify them so that you live to smile tomorrow. It looks hectic and looks like you're wasting time doing these things, but you will appreciate these things. Because remember, guys, one question that you botch because of a mistake can cost you a distinction. And what if you need a distinction to go and compete with others for a particular spot in university? You get these things. Or what if you need this distinction to perhaps achieve something in the short term? You will be shut out. So please don't take these techniques for granted. You may lose time for the rest of other questions, but what if those questions are really not going to compromise your distinction? Let's say you did not even know how to solve them. Maybe these ones that you're going to make mistakes on are the only ones you could solve in the question paper. And perhaps if you did, you would have gotten yourself a decent mark, a passing mark for that matter. Now you'll end up failing because you're busy chasing things you're probably not going to solve fruitfully or successfully. So be very careful. That's what I'm trying to say, guys. Whatever you do, always ensure that it is done perfectly and correctly and there's no looking back. So that even if you don't go any further than that, at least you guarantee yourself a spot amongst those who pass the test, amongst those who excel in the test. Because what matters is to be where it matters, not to be where you wish you could have, you wish you should have, you wish it could be you. No, you just have to be there. Okay, wow, I'm tired, guys. I should stop doing these videos now. So our answer holds. Changing this holds. How many marks was this? 3. Using exponential rules, maybe. Sounds right. So yeah, I think that's where those marks sit. But again, one can check the formal marking guidelines of this paper and get it done. So we are given that rational inequality, right? Now we're told to solve for x. So this is easy. 2.2. I'm but distracted. 2.2.1. We've got x plus 5 over 2 greater than minus 2. This is over 1. In this case, we are free to cross multiply. Why do we do so? Because the denominator has a known sign. It's a plus 2. And the denominator for the other one also has a known sign. It's a plus 1. Even if it was a minus 2, we would know what to do. Because we don't cross multiply with a denominator whose sign can either be positive or negative. We first need to establish what sign is it. If we can do so, then we can cross multiply. But if we can't, we transpose and solve. Okay, remember that. So this implies that x plus 5 is going to be greater than minus 4. The sign doesn't change because we multiplied across by positive numbers. Therefore, x is greater than minus 9. Nice and easy. So this is it. We're done. It's simple, it's straightforward. How many marks? 2. Great. So I guess getting here and here is good enough. So we've got 2.2.2. If x is an element of real numbers, represent the solution for 2.2.1 on a number line. That's easy. So we can have here minus 9. Right? Yeah, why not? Maybe if we like, we can show some 0 there just for the vibes, I mean. So we know that this is not included. So our solution goes stuff like that. All right, okay, all right. So we get just 1 mark for showing an open circle with an arrow, because values greater than minus 9 are going to the right of minus 9. Values less than minus 9 go to the left of minus 9. Okay, nice question right there. 2.3. We are told to solve simultaneously for x and y. Now I like this way of asking this question because grade 12s choke when they see these questions, because they forgot what they were taught in grade 10. Because usually what chokes them is grade 10 questions. Of course, grade 10 higher grade questions, because this is a grade 10 higher grade question, but I promise you it can choke grade 12s when they see this in the exam, because they are so used to the common quadratic, solve for x, factorization, quadratic formula, inequalities, using whatever has been taught to them well. And then when you bring in these silly algebraic expressions, and then they're like, what on the Lord's earth is this? It is what it is, folks. Now, if we look at this, we will appreciate one thing here. There's 2 ways we can solve this problem right here. There's 2 ways we can deal with this issue, but the 2 ways are going to be a bit unkind. You get it? Now, a student would be forced to say, look, I can change this factor to look like that and say x into x minus 3 plus. In fact, instead of plus, I pull out a negative. I get minus y into x minus 3 equal to 0. Then I've got the highest common factor here, which is x minus 3 into x minus y equal to 0. And of course, the usual way, x is 3 or x is equal to y. But do you realize that when x is equal to y, what happens here? This thing becomes 0. And if this thing becomes 0, what happens? We are dead. So if you're saying they are not equal, so what should it be? What should it be? Do you see? Now we don't have a way of solving for y here. Because guess what? When x is 3, look what's going to happen when you substitute back into the original. If this is 3, guess what? That becomes 0. 0 multiplied by anything is 0. So this kills the entire thing. So there are certain techniques that are going to sell you out as a student. Be very careful of how to deal with those issues. Yeah, it would be nice to say x must not be equal to y, but because we are solving for both x and y, we cannot go about it this way. Here we are not solving for p and k, and we understood P and K were nothing but constants. So in this case, a different approach. So be very careful. Of course, the first time you see it, you think about how you're going to go about it. Then when you get stuck, deal with it differently, because you can't repeat the same thing and expect a different answer. So basically, guys, if we are adding two things and they must give us 0, it means each one of them must be equal to 0. Okay? Means x into x minus 3 should be 0. And this one is not an or kind of a situation. And y into 3 minus x must also be equal to 0. That's the only way we can add those numbers to 0. Otherwise, it's not possible. It's not possible. Are we clear? Yes. Yes. And yes. Right. Now let's see. This one helps us to be able to solve for x. So we can see this implies that x is 0 or x is 3. Right. And y into 3 minus 0, for example, is going to be equal to 0. And we can say safely, you get it, therefore x is 0 or x is 3 and y is equal to 0. Right. But we need to state it that here, when x is 3, this is going to be 3 minus 3, that's 0. This already goes. So what does this mean? It means x cannot be equal to 3. Otherwise, if x is a 3, we are in trouble. If x is a 3, we cannot solve for y. Do you get it? So look at these expressions, guys. This is a higher grade question too, as you could see. And it would choke a student who doesn't know what they're doing. But it's nice to just get those solutions, but then you realize, hell no. It defeats. So it means x is 0 and y must be 0. And it makes sense because 0 multiplied by any number is 0. 0 multiplied by any number is 0. So 0 plus 0 is equal to 0. Left hand side equals the right hand side. But we cannot have x as 3 for the fact that if that's the case, we are not able to solve for y, because y literally is undefined, because we cannot divide by 0 to evaluate y. So please, guys, be very careful. These questions are very nice, actually. First of all, folks, this is key, and that is key. Right? Right. I believe splitting the solutions is the key factor in knowing how to solve further. Because these parts right here literally boil down to this. Bearing in mind that we need to restrict the x values for us to be able to solve for the y values. Very nice questions. Very nice questions. So as you can see, when we take these values back, we get what we want. Okay, let's get to the next question. So 2.4 says during a fundraising event, only 10 rands, 20 rands, and 50 rand notes were collected. Okay, right. In the final count, there were twice as many 20 rand notes as were 50 rand notes. Okay, and 15 more 10 rand notes than what is this, 50 rand notes. Okay, again, this is another higher grade 10 question. Even grade 12s will choke when they get here. Believe me, they will. So question says now, if 10,150 was collected in total, mind you, this is how much? 10,150 rands was collected. Determine the number of 10 rands, 20 rands, and 50 rand notes that were collected. Okay, so now this question is silly. You need to think about it. You need to think about it very well. Now, you can see that this looks like simultaneous equations in a way, but it doesn't, it's not. It's a matter of strategy. Now we can see that what seems to be involved in the number of the others is this dude. So we're going to use that guy as our anchor. We're going to say let the number of 50 rand notes be X. This would imply that the number of 10 rand notes is going to be, we said there were 15 more, meaning the number of this one, we would add 15 to get the total number of the 10 rand notes. So this would be X plus 15. And number of 20 rand notes is going to be twice. Twice is basically 2 times X. So can you see, we just represented everything in terms of X, because the numbers of the others are related to the number of the 50 rand notes. So this is what we call critical thinking and problem solving skills, basically a level 4 type, because here it's higher grade. Remember, higher grade is level 4. What fits both standard and higher grade is level 3. Then level 2 is standard grade. Level 1 is lower grade, which is a disgrace if you're a student of maths and you find yourself doing maths in lower grade. No. And you guys are always ignoring that mathematical literacy thing. That thing is difficult, yo. In my opinion, maths lit should be compulsory for all students. I'm proposing to you, department, if any one of you is watching and perhaps has some meetings with the Department of Education, please, maths lit should be compulsory for all students. Ne? Please, it should not be either or. All students should do maths lit. Then pure mathematical students or pure mathematics students can make a choice of whether we want it or not. But I think maths lit is compulsory, guys. I've seen the topics that are discussed there, how to evaluate and read, financial documents. I think that would help us a lot when it comes to financial literacy, to know how our money is used and all those kind of things. I think those are crucial topics, because for all of us, we need to know those things. And it's not that easy, by the way. There are some higher grade questions there that I believe pure math students would not be able to solve. Of course, if they were to be given those questions without having been taught the topics, they would not just think about it and be like, I'm a pure mathematics student, I would know what to do. They would have some difficulties there. So for me, maths lit, as much as people look down on it, I did too initially, because I was like, maths lit is nonsense, man. It's rubbish. And no, I was wrong. Actually, I take that back. When I saw one of the great tutors on YouTube, who is also a teacher, teaching that maths lit, I started to appreciate the significance of that subject for all high school students. fact for all schooling students, because that thing has some very important issues there. Knowing how to read your salary advice, things like that, so that you can be able to know when someone is playing you, not playing you, knowing when you're buying from shops what's going on, so that you are well aware of what is going on, and so you can participate in changing policies and things like that, because these are things that affect us in general. So Maths Lit, guys, it's not as ridiculous as we all think it is, but I feel it's a compulsory. It's one of those subjects that should be made compulsory. We cannot make pure maths compulsory. Not everybody can do pure maths, but I think everybody should know Maths Lit, because that's what we live to do all the time. Even the people who say I hate maths, but if you think about it, when you go to the store and you purchase items for the family and stuff, to some extent you know how to evaluate and analyze those pieces of information, but you're not really analyzing them at a, at a level of some serious knowledge of what is going on. You just see what you see, but in a way you get to understand to some extent vaguely what is going on. But I think when you come to those things with the knowledge that you would gain from Maths Lit, you become a bit better at evaluating what's going on. And I believe that is very important, because a lot of people end up relying on bankers for their money and brokers for their investments, and at the end of the day, whenever those people issue them those documents on how their investments are growing, they can't even read those things. So they will not even know when something is bad, because remember, brokers want to get paid. So their job is to convince you that their product is doing well for you. But if you were to say, okay, give me the papers, I want to see. If you know these things, as you would if you do Maths Lit for sure, then you start to realize, hold on, this is not good. Actually, I'm bleeding money and these people are making money off me. So it would stop a lot of these financial bullshits that we end up being subjected to. Anyway, guys, enough of the nonsense. So can you see, guys, once you plan, remember certain questions, you're not just gonna go through them nicely like that. It takes a lot of proper understanding and separation of things and linking them up again. Now, do you see, guys, if we're saying the number of 10 rands is x plus 15, the number of the 50 rands, if we solve for x, then we will know how many 10 rands. We will know how many 20 rands there were, right? Right. We can say then what do we say? We know that the 50 rands are x, right? We're going to have x into 50 plus, remember, we're going to add this money. Then the 10 rands is going to be 10 rands perhaps into x plus 15, right? Doesn't really matter how I'm structuring it, but remember, this is the money that we get, so we need to multiply the number of each so that we can get the total. So this is going to be 2x into 20 or 20 into 2x, whatever. So we can say 2x into 20 rands is going to be this 10,150 rands. That's what this is. Nice equation. This implies, of course, guys, we can ignore the rands at this point because it doesn't really help the situation right now. So this one was 10, right? For 10 rands. And so this basically gives us 50x plus 10x plus 10 times 15, that's 150, plus 40x equals 10,150. Now, what do we have? 50 plus 10, that's 60, plus 40, that's 100. And then of course 150, when we take it over, we end up with just 10 squared. Okay. Now we divide by 10, we see that x is actually going to be 100, because 100 squared is 10 squared. Nice, 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 nice. So it means there were 150 rand notes. So we can say, therefore, making a conclusion now, there were 150 rand notes. Then here we're going to say 100 plus 15. We're going to say there were also 115 10 rand notes. And basically 100 times 2, this is 220 rand notes. Nice. Okay, this question is a wonder. It's a very nice question. All right, so can you see, guys, a lot of planning and a lot of thinking is key in solving questions of this nature. These are not questions you answer first, because sometimes you don't see what you need to do. But if you're good at this, you've been doing this, you'll probably know what to do. Okay, so this is easy. And of course, we can check by multiplying these monies with their numbers. So let's say, for example, 50 times 100, we get 5,000, right? Plus, now we've got 115, 115 into 10. This gives us 6,150. Plus, then we're going to have, what was the other one? Okay, there's 150 rand, so this is going to be 100 into 50. That's into 100 times 50 plus 200 times 20 plus 115 times 10. That's 10,150. So it means we are good. We have done our job. So 4 marks. So remember, the question was on the number. On the number. So 3 marks there and 1 mark for solving for x. Can you see how mean the examiners are? Very mean. But I don't think that 100 matters for now, because it's a mark over there already. So that one is out. I suppose formulating this equation is key. But again, this is something that should be worth sub 5 marks, because these for me are critical. These are not things one should ignore. At least those two. Choosing for the 50 rands is easy, because that's just the beginning. So for me, this should have been 6 marks, because I still believe knowing this is what needs to be done is good, because without doing it, there's no moving forward. Anyway, let's move on, guys. Now, sequences and series, I'm not going to go through them. They are not part of what you're going to come across for now. Some financial math as well. Not really. Now, let's just handle functions quickly and finish this review. Oh, by the way, how many marks was that? It doesn't really matter. We've gone through those questions nicely. So sketched below are graphs of f of x equals k over x plus q and g of x equals x plus 2. So basically, we're looking at our graph. It appears in the first quadrant and third quadrant. So what does that mean? It means k is greater than 0. meaning k is a positive number. So these are properties we need to now already accept before we actually move around. Well, q is the horizontal asymptote. So this means this is the horizontal asymptote, right? Now, the horizontal asymptote is as what we see over there. So it means q is 1. So this means the equation here comes up as f of x is k over x plus 1. So this is very important to note, so that as we progress, we do our thing. And then, of course, the straight line equation, positive gradient of 1, y-intercept is at 2, so it means there we've got 2 where it cuts the y-axis. But we can also work out the x-intercept by substituting g of x with 0. We solve for x, we get minus 2. So it means point B is actually minus 2 and 0. And we can see it's a common x-intercept for the hyperbola as well as our straight line equation G. So literally this gives us point B nicely. All right, so this is as much as we can do with that. So we're told the equation of the horizontal asymptote of f is y equals 1. My lord, it's already given, guys, on the graph. So this is too much information. Why? Graph G cuts the x-axis at B. It's evident. Don't need to even explain it. Again, why do you want to give so much? It's obvious. A student needs to look at the graph and see. This is too obvious. Perhaps a turning point would be a different story because you don't know where it is. Graph of f and g intersect at A and B. Again, it's too obvious. We can see it. Sometimes they like to talk, just like me. Anyway, leave my nonsense. Let's answer the questions. So 5.1. Question says write down. So what does it mean? Answer only. No explanations here. The value of q. So we know that q is 1. 5.1.2. The domain of f. F is the hyperbola. So we know that x is an element of all real numbers, but there's a restriction. X cannot be the vertical asymptote. X is not 0 because we can see the y-axis are being approached by the graph, but it never really intersects them. Great, so we get 2 marks for this domain and the restriction to it. Right, so 5.2. Now the question says determine. Now remember, a determination is open-ended. This is an open-ended question, so it means we can do this by inspection. So determine, we can present an answer only, or we can show how it was worked. But there's no restriction as to how we solve here. So here we do however we please. But take note, I would say in everything you can do, note the mark allocation. Note the mark allocation, because this will decide if you're going to give an answer only or more than that. So anything that is 2 marks here, let's just say 2 or less, is what is worthy of just an answer only. But anything that is perhaps more than 2 marks, you would have to show here. So this is when we have more than 2. Because here, even if it's an answer only, it must include some form of a restriction or a reason for the answer, something like that. So it helps again to know how to answer based on the questions, right? Not to just answer because you know how to answer. So asophendule into ongayibuzwanga. Phendula le nto uyibuziwe futhi ngale ndlela uyibuzwe ngayo okanye ngale ndlela ifuneka ngayo. Answer what is asked and answer it in the manner that it is required in, or in the manner that is best for the kind of question that we got, okay? Remember that. Remember, this is an instruction. It has to be followed, failing which we get penalized. Now we need to determine the equation of the line of symmetry of f with the positive gradient. This is easy because where do the asymptote meet? At that point where 0 is to 1. So the line of symmetry passes through there. And it has a gradient of 1. So meaning it should be parallel to that line. Sorry. We can even try to use this one because this one has a gradient of 1. So it means that line should be parallel. To that other one. So please know these things, folks. Please know these things. If you don't know these things, they will catch up with you. And when they do, do not cry. And pretend you were not shown. So that would be our axis of symmetry. And we can already see that it has a y-intercept of 1. So we'll just write here. We don't need to show how we got it. So this is going to be, this one with the negative gradient. Sorry. So this is the one that we want. So if that's the case, the one with the negative gradient should be perpendicular to this line or perpendicular to the other one. That doesn't look perpendicular. Come on, man. Okay, that's better. So this one passes through there. Okay. So the axes of symmetry are themselves perpendicular to each other. Why? Because their gradients are negative reciprocals of each other. So this is the one we are looking for. And of course, we know the gradient is -1 and it passes through 1 on the y-axis. So this is minus x plus 1. Very easy. As you can see, knowing the gradient and the y-intercept is what matters. So 5.2.1, for what are you doing? Now it says, okay, we need the equation of f. Lovely. And of course, you can see this is 4 marks. So here you can't just write the answer only. So we need to work it out. So we know that f of x is k over x. Basically, we need the value of k plus 1. We saw that. That's how that equation looks. But now, we have a situation. We need the coordinates of b. Right? We need the coordinates of b. In fact, it is best to start with the coordinates of b. Because once we write that, we need to start substituting. We know that b is such that 0 is equal to x plus 2. Right? Why? This is the x-intercept of g. And f. Okay, this implies that x is going to be -2. Therefore, b has these coordinates. This is key. We need to showcase it. We can say here then, we now take our friend up there. So watch the method that I'm solving this in. It's methodical, systematic, and easy to follow, and very directive at best. So try to do this as well when you solve. So f of x is y, so we substitute 0 there. This is going to be k divided by minus 2 plus 1. This implies we transpose. This is minus 1 over 1 equals k divided by minus 2. Cross multiply here. We'll see that k is going to be 2, because minus 2 times minus 1 is just 2. And do you see, we expected k to be a positive value. Therefore, f of x, we write the full equation is going to be 2 divided by x plus 1. Great. Now, I'm a person who likes to argue though. If we write this equation, is it okay to write this equation without its domain? I don't think so. It's not correct. Because remember, this thing needs to make sense. So we know that where x is an element of real numbers and x is not equal to 0. Because this equation, for it to exist, its restrictions need to be respected. For me, if we write an equation, it's not nice to just leave it like that. We need to state exactly how that equation works. For me, I feel like the domain is key, but since the question on the domain was asked above and it relates to f, I think it's fair to leave it out. We can say perhaps it's optional. But if there was never a question on the domain, I believe it is unacceptable to write. Of course, remember, this is my belief now, it's my opinion. It's not the guidelines, it's not the rules. I believe, though, for this equation to ever make sense to anyone who reads it, it is good to write the domain alongside the equation, because this equation needs to be valid. And for it to be valid, there is a restriction on the domain. We don't really care about the range per se. On an equation, the domain is much more important, because the domain is the set of inputs. What comes out will be restricted by the domain anyway. So that's just the idea. So I hope we are good. I hope we are clear. Right, so how do we do this? Finding the coordinates of B is key. Substituting this is key. Then writing the equation is key. Now, where's the other mark? Perhaps getting 2 coordinates of B, maybe. Or one can say, knowing that we need to substitute a 0 there. That's also good. Because remember, this is a determination, so we need to show everything, depending on where the marks sit. All right, okay, all right. And then, of course, if the domain was never asked above, we would then have to include it as part of the solutions. That would be worth a mark, I suppose so. Because remember, in grade 10, you don't know much, so you have to really stay on the line. And to stay on the line means respecting restrictions. Anyway, we need to find the coordinates of A, the points of intersection. So this is simultaneous equations. Again, very easy stuff. So we know that A is such that 2 over x plus 1 is equal to x plus 2. Now all of this is over 1. can cross, oops, wait, it's too soon. It's too soon to do that, so we don't want to do this as yet. Oh, it looks like I'm gonna need some time. Okay, let's try and see. Multiply, there we get 2 plus x over x equals x plus 2 over 1. Then we cross multiply. What do we get? We get x squared plus 2x is equal to x plus 2. Transpose everything, we get x squared plus x minus 2 equal to 0. This implies we can factorize by inspection. So this is xx plus 2 minus 1. So therefore, x at a is equal to 1. Remember, we're going to ignore the minus 2. Why? Because it is b. We already spoke about it. We can say, therefore, y at a, I'm just going to waste space now. Okay, maybe let's not do the wrong thing. Once we get here and we are seeing that we need to continue elsewhere, we need to show that the solutions continue. So we can say, therefore, y at a, substitute into the linear one, which is easy, 1 plus 2, which is 3. Therefore, a is 1 is to 3. Remember, if we don't show the ordered pair, we are dead. Even if it's not a mark, we lose a mark for not showing it. Okay, so we're scoring 5 marks. Equating the two is a mark, right? Right. I think so. Remember, whenever we factorize, it's a very, very, very important thing. That should be a mark, right? Right. And then to show the substitution is a mark. Then we get these guys. I think that's how we score those marks. But again, it depends on how the examiners decided these marks are going to be distributed. Yours is to do everything in your power to get it done. Okay, so we're taking some easy 14 marks here. Easy stuff, guys. So let's get to the last question. Question 6. So this is probability. We will discuss it in term 3. So let's look at question 6 quickly. Question 6, the graphs defined as g of x equals ax squared plus q. We know that this is quadratic, right? And f of x equals k to the exponent x. Please don't say k to the power x. Now this is an exponential. Okay, they both pass through this point. So what does this make it? A point of intersection on the y-axis. Why? Sorry, on the x-axis. I was going to say y. On the x-axis. How do we know? Because the y value is 0. So that's an x-intercept of both. So please, guys, be in the habit of, I don't know what that is, you know, this stupid cell C. Running here again. Abame. Abame again, I don't know why I didn't pause the damn thing. Now, guys, you saw my indabas. Hey, send me indabas. Zawudila nazo indaba zami later. Okay guys, masigqibezele. So okay, the y-intercept of G. So can you see G? We are given the y-intercept. So what does that mean? This means this minus 5 is Q. Because the y-intercept in a parabola like that is basically the turning point as well. So it means this is a parabola that turns right there. But then we don't see the graph, so we don't know whether this graph is concave up or concave down. We don't know. So we don't know which one is which. But all we know is that there is a turning point at 0 and minus 5. Now, if I was to ask that question before we start answering anything, what would you say? Of course, you would know this one would not work because we already have an x-intercept that exists. So for this graph to have an x-intercept, it already tells us that this graph is concave up, because a graph like that, if this is minus 5, will have an x-intercept if it is like that. Otherwise, if it was to be like that, there is no x-intercept. Can you see? This one does not intersect, but that one does intersect. So please, folks, trust me, these small analyses, they look crazy, they look perhaps overreaching or whatever you would call it. But the reality is they make you better at this business. And you start to love this thing because you will know you are on par with every challenge the examiners had in mind for you. So you can see, you just look and see, okay, what do I have? What does it mean? You get it? So obviously we know that a parabola, standard parabola that is only vertically shifted, the y-intercept is exactly the turning point or the minimum value or maximum value depending on the shape. But if this was to have an x-intercept, then it means it is a graph like this, and we saw that this is minus 2 now. Okay, right. Now we've got an exponential graph here that has an asymptote at minus 4. So this one, if this is minus 5, we can say minus 4 is over here. All right, what are you doing? This one is an asymptote. So we know that here we have minus 4. So what does it mean? Well, there are two things. Again, depending on the coefficient here. But again, we know that the base itself, we don't really care. The coefficient of that base, the coefficient is an invisible one, which is positive. So it means our graph is going to appear above our horizontal asymptote. But now there's two issues. Is it like this? Or is it like that? So we don't know, because we've got two options for this graph. It's either it looks like that or it's a decreasing function. So which one is which? Now this is where it hurts the most, because yikes. Isibetha ngentonga emqaleni. Sigwinye ingweqe bantakwethu. Ngiyaniqerera, ndiniqerera kakhulu ke ngoku. Now ithi ke ngokulendelena kusezawusetyenzwa. So I'm sure you guys can see what's going on. This one we saw that it does not apply. It's out because definitely we have an existing x-intercept for the parabola. So this means this should be G. This could be F. This also could be F. So there's two possibilities for F, and we don't know which one is going to work. So this means we need to check now if k, for example, is greater than 1, when k is greater than 1, this is the graph we are going to get, the gold one, right? When k is less than 1, but greater than 0, because k can never be less than 0, or equal to 0, or equal to 1 for that matter. Then, if that's the case, then we would get this graph that's decreasing. So remember, guys, we're just playing with the knowledge that we have, because sooner or later, it's coming. It's coming. So it might as well be clear from the word go. Okay, let's start answering some questions. So the question says, write down. Can you see? No explanations unnecessary. The equation of the asymptote of f. Okay, we know that the asymptote is always the vertical shift itself. So we know that we will write y is equal to, but usually since our standard graph, we write q, sometimes we write y, I don't know. It doesn't really matter though. This is y is equal to, because y is the y-axis, right? This is where it cuts the y-axis. So we'll write y is equal to 4 minus 4. Okay. So that would be the asymptote. Easy. Just look at the equation and we know what we're looking for. Oh, we're supposed to be down here. Okay, 6.1.2. The value of q. Now, what is the value of q there? It's the y-intercept we saw. We can write q is equal to minus 5. Again, by inspection and understanding how things are related. 6.1.3. The coordinates of the other x-intercept of g. Remember, the x-intercepts of g are symmetrical about the axis of symmetry. If this is 2 units to the left, this is going to be 2 units to the right. So this should be 2 as well. Again, by inspection. But remember, the question said coordinates of the other x-intercept, but coordinates. So we know that this is going to be 2 and 0. Knowing the axis of symmetry, that this is going to be symmetrical. All right. So can you see, guys, we're cruising here. No issues. And in fact, for this one, we're going to get maybe 2 marks. Ah, just 1. Here when okay, determine. Now again, this is a nice one, open-ended. The equation of g. So how do we do the equation of g? Very, very easy. But there's a catch here. We need to find the value of a. And the value of a, we cannot just look in the graph and know. We need to find it by calculation. I'm a bit sad that that is 2 marks. Because the equation of f as well, in fact, both for me, both need, they both need 3 marks. I feel like that should be 3 marks. It can't be 2. It's not that simple because they both require a similar pattern. So, in fact, the first one to get 3 marks should be G, because F is going to be answered in a similar manner as G. Then we can say 2 marks there. Doesn't make sense to give 3 here and 2 up there. I don't see why, you know. I doesn't see why. But hey, it depends again on the gymnastics, I guess. Because if you think about it, all is left here is just to substitute. So we can say, well, g of x is ax squared minus 5. We saw this. Then we can substitute any of the points that we got, wrong or right. But I think the one that was given is better. 0 is equal to a into minus 2 squared minus 5. Then this implies that 5 is equal to 4a. Therefore, a is 5 over 4. We can say, therefore, g of x is 5 over 4 x squared minus 5. So I guess the mark here is on the substitutions and the full equation. Maybe. There's not much we did. So let's leave the argument. So it means my argument was invalid. 2 marks is good enough. Okay. Sometimes, most the guy talks and forgets that here when whatever you see sometimes is not exactly what you think you're seeing. Eh? Sometimes it is bonela and just bochond. Now this is bang, guys. Ninganthathe serious. Yo, nganthathe serious nizobanga mageza njengam. Anyway, 6.2.2. We need the equation of f. Of course, we will deal with it. So we know that, well, f of x is k to the exponent x minus 4. Again, b was given for the 2. So this is minus 2 and 0. 0 is equal to k to the exponent minus 2 minus 4. Well, we transpose 4 over 1 divided by 1 over k squared. All right. So what do we do? Cross multiply. So what is the story here? We get k squared is equal to a quarter. Therefore, or perhaps it will also show that k squared is equal to a half to the exponent 2. So same exponents, and if these things are equal, it means the bases are equal. So we then write, okay, this one warrants 3 marks. There's quite a lot of gymnastics here. Therefore, f of x is a half to the exponent x minus 4. So which graph wins the crown? Is that one, the decreasing function. This one gets slashed because we saw now that k fits that parameter. So can you see, guys? Can you see that things that we do must tell us what we should do? Right? Let me tell you guys, if ever that was the case, let's not mess it up. But what I can tell you is usually the vertical asymptote, I'm not sure if I'm right to say this, if this is negative, I can tell you, usually, you will notice that the y-intercept is not so far from this. So you would expect a negative number. It never really gets so wide. If this is negative, you will hardly have a positive y-intercept. You will hardly have but let me not say too much, because I will make you cry. But honestly, guys, I have never seen, though, the distance between the y-intercept and the asymptote being so large. They are almost always a unit apart. I don't know if I'm right to put it that way, but they're almost always a unit apart. Let's work it out right here. You will see that if we put 0 for x, this is 1. 1 minus 4, that's a 3. Minus 3. Can you see it's just a unit from minus 4? So what I can tell you is that here's another note. I don't know if it is correct, but I'm going to write it anyway. We can say for an exponential function, we can say the y-intercept is always a unit from the horizontal asymptote. Right? Right. So that is what something is distracting me actually. Let me just look at it quickly. Anyway. All right, folks. So that is, I don't know how true this is. I'm just thinking about it. It's just something I've been noticing, but I'm not sure if it is. Now, this is what you call notes, folks, not the things you write down, just reproducing the notes and calling them notes. That's just not notes, man. That's you transcribing things that are already written down on the book. It's there in the textbook. Why not read it again? Why must you write it down by hand? Do you think you're going to remember it? If you don't understand it, you're not going to remember it. I promise you. Unless really you're that relaxed in the exam. So I think this is a very worthy note. So these are the things you would want to note down. That every time you're looking at an equation, you know that the y-intercept is always going to be a unit from the horizontal asymptote. That is the case always. But again, you will look and then say, okay, fine. If this is the horizontal asymptote and perhaps the graph comes below that horizontal asymptote, then it would not have an x-intercept of -2. So already this would have directed a student into that graph that we just said is the one, okay? So this is one of the things, guys, that I think you can take as many exponential equations and look at them, guess what it should look like before you work it out and draw it on the Cartesian plane and prove if what I'm saying is true or not. These are things you do when you study. You notice things, you postulate, you whatever, then you check it, whether it holds. And then again, when it doesn't hold, look at it again and see why it doesn't hold. Don't just say, it doesn't hold, and stop. Try to understand why it doesn't hold. And also understand when or under what conditions does it hold. Or does it hold always? Okay? Then you will be comfortable when a question that is a bit naughty on this. Perhaps someone just says, draw the sketch. You know, some questions can come and say, well, f of x is equal to kx minus 4. And of course, we are told that -2 and 0 is the x-intercept. And then someone says, draw the sketch without any workings. How would you know what to do? Exactly my point. If you don't have this pearl right here, you wouldn't be able to tackle this. And again, this thing is not written in the books. This is the stuff you notice by studying these things. You don't just solve and move on. You solve and then say, hold on. What am I noticing? And you wouldn't notice these things if you didn't start by drawing these sketches, right? The possibilities for the function f. And then start to see, oh man, come on. This thing is never more than a unit from the asymptote, actually. So then I know what is going on. You get it? Yeah, man. Because in the NPTs, you'll be punched with questions of this nature. And you don't have calculators to work out anything. Sometimes these kind of things become your absolution. Anyway, guys, that was just me. You know, must be me in a way. That was me being me. So how many marks was this? 3 marks. Okay, substituting this point. Yeah. And this exponential gymnastic right here. Yeah. And of course, we write this whole thing. Definitely. Here, we don't need to write the domain. Why? Because it's unlimited. Once x is an element of all real numbers and there's no restrictions, then we don't need to show it, because it doesn't matter how one looks at it, it will always hold. But things like hyperbolas, where there's restrictions, I think an equation should always be accompanied by the restrictions and the domain of the inputs, because they sort of like influence the limitation on the output values. Here there's no limit, so literally we are good, because this is already going to work out for every x value we put. We'll always have a y value. Right. Now 6.3. 6.3 says calculate the y-intercept of f. Okay. F of x is 1 over 2 to the exponent x minus 4. So we can say y-intercept is such that f of 0 is a half to the 0 minus 4, which implies that f of 0 is going to be 1. Remember, any base to exponent 0 is 1, minus 4. Therefore, f of 0 is minus 3. Therefore, the y-intercept is going to be 0 and minus 3. Okay, good. So this fact we just spoke about is now being nicely exposed, and you will probably understand that even for a standard exponential equation, for example, let's just take this one. If this is the x-axis origin, if it is not shifted, it's going to be 1. But even if we shift it, let's say we shift it up by 1 unit, do you know the asymptote is going to come to 1? And that graph is going to cross at 2. But what is the distance between the asymptote and the x and the y-intercept? 1 unit. So know these things, folks. They will haunt you if you don't notice them. This is why you cannot take what you see in this channel for granted. But do it at your perish. And I will be sitting on the other side to welcome your ghost and torture it some more. I'm the one who's going to be torturing you for life if you ever fail maths, because I'm going to keep showing you where you missed it, because my channel is going to be around for a while. And every time you look at it, you'll start to realize, why, when I had the luck to bump into this channel, why did I not subscribe? Well, it was ignorance. Why did I not look at all the videos in the channel? Well, ignorance. Then look what I missed, because I promise you guys, if you trace the chronology of the papers or the exams that have been written so far from the inception of my channel in 2021 until now, you will see something very strange. That some small things I keep talking about, they tend to come in the next exam. And they play a very, 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 very significant role. Do not take this for granted. Of course, it's usually 1 mark or 2 marks, 3 marks at best. But you will see though. you will see though that if you already have this up your sleeve, it means you are good with the others as well. But if you don't have these up your sleeve, it means you're going to struggle with the others still. Anyway, uthetha masenze. So substituting 0 there and getting that coordinate, provided we present the ordered pair. Remember, final answers don't always get a mark, but they need to be there. Right. Or it could be a mark for the final answer. But the question said calculate. In fact, answer only here is dangerous. Even though this is 2 marks, you cannot give an answer only. Answer only not accepted. Because we need to show a calculation. As you can see, how questions are asked is very important to gel with that, okay? Now on the same set of x's, sketch the graphs of f and g, show all the intercepts at the axis and asymptote or asymptotes. So we already know what this looks like. 6.4. Re qetile bana beso. Mosebetsi wa rona o fedile hona tjena. X, Y, origin. We saw that our parabola is doing its things like that. Phansi yabayiyo kodwa masishifte kancane just so that it looks nice. Ngathi siyalingana ke ngoku. Xa silingana singayamkela sithi wamkelekile ebhodwe. So we saw that this is -2, this is gonna be 2. Masishifte kancinci ihlale kulam sithi ngo-5 lo. Then we saw that our friend is going to approach this line, asymptote line. So we dash this one to show it's an asymptote, and we saw that the friend is a decreasing one. Perhaps not quite good. Angiyithandi. Akeyithathe. Ya, ngiyayithatha ke coach. Ngiyayithatha ke coach. Anyhow. Right. So that's our graph right there. So we know that this one is at -4, right? That one is at -3. That one is at -2. And is gqityiwe, then we just label this is F, this is G. Is there anything missing? There's nothing missing there. 3 marks for each. Shape, intercepts, turning point. The other one, shape, any one of the intercepts, and the asymptote. Great, so we are done, folks, for a nice 6 marks right there. And we are taking these easy 16 marks. You know, so I'm very happy, guys, to show you more, but I don't want to create a situation where you want to see me work, then you actually do the work. My job is to show you how to use what you have and how to get comfortable with the subject if you consider yourself a true maths student. A true maths student is always discovering things. within what is already discovered, because there are certain things you will not be taught necessarily at school. I mean, some things I had to find out by myself. My teachers didn't tell me. For example, my 3-step approach, I wasn't taught at school. No one showed me that thing. I figured it out because I kept on understanding. You know what pushed me in that direction is failing those higher grade case sheets at the beginning of the year. Because I started to think that, well, how do I deal with higher grade questions? What makes me survive? Let's say, for example, I don't get the right answer, but how do I ensure that I get some answers, or at least some marks in a question? I started to realize, man, look, every time we work, this is what we do. Every time we work, this is what we do. Okay, all right. Now, can I take this very same thing and just use it on every higher grade question that I come across? And it seemed to work for most, but then it still did highlight the fact that some topic-specific, issues need to also come in. And that's when the step 3 of those 3 steps came in, because the main ones in my mind at the time was BODMAS or factorizations. And of course, the adaptation of BODMAS to reduction formulae, special angles. But then I realized, okay, there's some topic-specific issues like identities, like, laws of exponents and sets, some theorems in Euclidean geometry, even logic for that matter. Then you started to realize, okay. Now I'm getting better at this, and I can promise you guys that thing is solid. But it's not going to solve every problem easily. But as you could see, when we solved, what was that question about? The one with the money. Can you see? The one with the money is a bit wide. It means one has to be comfortable with the stuff, because first of all, we know how to solve equations using BODMAS, inverse operations. But before we got there, we needed to structure everything according to the rules set out for us. See, this was a question-specific rule. Now, to set up those values, like we did, this thing likes to freeze sometimes, my lord. So I was wondering what is happening now. Do you see how we set up those issues there? Can you see? This was a question-specific thing. So all of this first part was I would say question specifications or question-specific issues. And if we don't apply them, we will not be able to proceed further with our BODMAS, because do you see, from question-specific things, logic puts us into formulating this equation. Then we solve it BODMAS, brackets off, inverse operations, solving for x. Then we have our answer. So these are some of the things I want to just make sure, guys, you cement in your mind, that every time something new is brought, there will be enough of information to use. But your logic cannot be, misplaced here. Again, knowledge of the subject should not be shaky as well. Because if those are not strong, you will not make it with questions of this nature. Because you will just not know what to do, not even how to begin. Anyhow, before I make this video too long, we cut it here. I hope you guys enjoyed. Otherwise, if you're interested, I can put this memorandum of mine in the description together with this question paper if you want to practice further, especially things like sequences and series and the probability, financial math, because I will still discuss this at a later stage for term 3. So I will have finished this question paper by your term 3. But I don't want to be too far ahead of your, is it curriculum or syllabus for the term. because at the end of the day, you're not going to be examined on things that are not in the term. So hence I'm narrowing things down to that. But I'm not too sure because, the schools also sometimes in the districts, the provinces do things differently. But either way, you still have to go through algebra and functions, because those two work hand in hand, like a hand and a glove. Okay, there's no separating this. But even sequences and series and algebra, they work hand in a glove. But the good thing is that hand in a glove, there's openings, there's pores there. It's not like functions. There's pores. And now those pores are the exceptions that one needs to appreciate. Anyhow, goodbye. Ndiyanlaga ke bantram, ndiyanihleka. So this is the paper, guys. Please practice it. I got it from testpapers.goza. You must speak Goza too. If you don't speak Goza, you're not gonna know maths. So you must speak Goza. Is it Goza? Is it Goza? You must speak Goza, man. Yeah, Xhosa. If you don't speak that one, you struggle. I'm joking, guys. If you speak Xhosa, you're gonna struggle actually. If you speak Xhosa, you're gonna struggle with maths. Don't speak it. Speak Xitsonga. Xitsonga is Xilungu, mas. Yeah, they will tell you that Xitsonga is Xilungu, that one. And if you understand the Xilungu, mathematics is pap and vleis, mas. You just sit at the table with a fork and knife. You just chow the thing and leave the bones for the dogs. All right. Anyway, guys, hey, so thetha nezinto ezirong ngupapa yini.